All right, this is a pretty interesting question, this one. I quite enjoyed this one. So a regular 50-cent coin has the shape of a regular dodecagon, and if you're not sure what that is, you can count the sides and you'll see there's 12. Oh, it tells you in the next bit anyway, polygon with 12 sides. 8 of these 50-cent coins will fit exactly on a $10 note as shown. What fraction of the $10 note is not covered? This is going to be a little bit of a challenge. Let's start with our dodecagon. What I've got there, I'm trying to draw this pretty carefully, is a right angle, and if I split it up more carefully, you will see I have 3 congruent triangles. And in fact, if I go right round the dodecagon and did that in every quadrant, I would end up with 12 identical triangles, wouldn't I? Now, I don't know what the side length of that triangle is, but I do know that they are all equal in length, aren't they? That blue pen's having a little bit of trouble showing up there, and I am getting a lot of other things popping up because I'm not... It's going to be too thick if I use that one. Let's find a pen that's going to hopefully show up just a little bit more. So that line there, that's looking a little bit better. That line there, blue wasn't quite dark enough or thick enough. Those 4 lines. And if I kept going around the thing, I have lots of little isosceles triangles there. I don't know what that distance is. Let's call it x, because why not? You could call it r for radius. It's sort of like a radius, I guess. But I'm going to call the side length there x. And if I find one of those triangles, then I can go ahead and find 12 of those triangles. And then I can go, that's one 50-cent piece. And I can multiply that by 8 and have all of the 50-cent pieces. So, all right, there's one triangle. I've got that. What does that triangle look like? Let's just have a look at it a little bit more closely. This is x. This is x. The angle in there, I've got a fair idea about. There are 12 of them all together. 360 divided by 12, that angle must be 30 degrees. So the area of one of those triangles is a half AB. Well, that's the 2 side lengths. X times the sine of the angle in between, which is sine of 30 degrees. What does that look like if I go a little bit further? Well, it's x squared sine 30 over 2. Sine 30 we should know. I'm just going to go over here and remind us of our best friends, little buddies. We talked about them today. Exact value trigonometric ratios can be found using that triangle there. So the sine 1, 2, and root 3. And we find the sine of 30 opposite over hypotenuse. It's a half. You could, of course, have done that on your calculator. Either way, what does that simplify to? It is x squared over 4. And that's the area of one triangle. Therefore, the area of a 50-cent piece well, it's made up of 12 of those. So it's 12 multiplied by x squared over 4, which is, of course, 3x squared. Now, how many of those do we have? 8 50-cent pieces. So the area of 8 50-cent pieces is going to be 8 multiplied by 3x squared. And we've got 24x squared. Well, that's great, Chewy, but you haven't really helped me here, have you? So I've got the area of those in terms of x squared, but how does that compare to the area of the $10 note? Well, if that's x, let me have a look here. That also would be x, as would that value, as would that value. And as you can see, the height of the $10 note would be 4x. I think you can see where this is going. If I go across, I've got 2x, 4x, 6x, 8x as the width. Okay, so the area of a $10 note, well, it's 4x multiplied by 8x, which is 32x squared. Now, they want to know what fraction is not covered. Well, let's start by finding the fraction that is covered and subtracting it from 1. Or you could just say, well, 32x squared minus 24x squared is 8x squared. 8 divided by 32, and that will tell us as well. Therefore, let's do it that way. Area not covered is going to be the total area, 32x squared, minus the area covered by the 50-cent pieces, which is 24x squared, which is 8x squared. Therefore, fraction uncovered, or not covered, equals 8x squared out of the total area, which is 32x squared, or just 1/4. All right, I hope that helps. That's a fun one. You can do that same thing by starting off with one side being x and the other being 2x, and then you just end up with fractions. It still works the same way. You still end up with a fraction covered is 3/4, uncovered is 1/4. Hope that helps. Cheers.